Hey guys, today we are talking about compositions of functions. So go ahead and label your notes. 1.5, compositions of functions. Okay, so I'm just going to get started in get in the thick of the explanation. Okay, so what we're going to do is we are going to find f of g and g of f. So if you have another colored pen or markers, you might want to pull that out because I'm going to be switching back and forth, and it really does help when you use different colored markers. Okay, so we got f of x is x squared, and g of x is 2x plus 1. Okay? So, first step, to find f of g, our g value is basically our new x value. So what we're doing is we're going to be substituting 2x plus 1 in place of x for here and here. So what we're going to do, we have f of g of x. And if I write these two statements here are exactly the same thing. So I write both of them. They're pretty much like f of x and y. Like they're pretty interchangeable. Okay, so back to it. So f of x is x squared, so I'm going to put that there. My new x value is now 2x plus 1. Okay, we are going to distribute the square. So 2x plus 1 times 2x plus 1. If you know the shortcut, you don't have to FOIL, but I'm just showing this for people that don't know the shortcut. So you get 4x squared plus 2x, and then you multiply the last terms, plus 2x plus 1. So our answer is 4x squared plus 2 plus 2, which is 4x plus 1. Okay, so f of g is this answer right here. Okay, now you're going to be surprised that it's not necessarily the same for g of x. Okay, which is the same thing as saying g of f of x. Do y'all see how f of x is now in place of my x value for my g? So again, this is what it looks like. Our g value is 2x plus 1. So I'm going to run out of space, it looks like. So I have 2 parentheses, my new x value, plus 1. My x value is my function of x, which is x squared. Okay? So it's not as much work involved with this type of problem because we didn't have to FOIL anything, but g of x is 2x squared plus 1. Okay? Now if we take it one step further, I want you to find, actually, you know what, I'm going to give another example, and I want y'all to solve. Okay, let's do, we've got, let's do example 2. Okay? We have f of x is the absolute value of x, and we have g of x is x squared plus 1. Okay? We have f of g of x. We are going to put our g value in place of our x. So our answer is, in this problem, the absolute value of x squared plus 1. Okay? If I asked you what your g of f of x is, you're going to do the opposite. You're going to put the absolute value in place of our x. So this one looks like the absolute value of x. Now, we can simplify this because when we square anything, it will always be positive. So in reality, our our g of f is actually our g of x. So that's not very common when that happens, but so notice the difference between f of g of x and g of f of x. Okay? This is going to be getting us working into finding different domains for these types of problems, and this next one's going to be kind of a doozy, so make sure you have a lot of room. On this one, we'll have a lot of practice tomorrow. Okay, so this will be example 3. So we're going to let f of x equals 1 over x, and we're going to let g of x equal 1 over x minus 2 plus 1. Okay? We are going to find g of f, and we are going to identify the domain of the composition. Okay? Now, our inner equation is the second term. So go ahead and write that. That's our inner equation. Okay? So, and you're going to do a side note. Okay? There's 2 rules when we're finding our domain for a composition function. First, our first rule is you're going to find the domain of the inner equation. So domain of inner equation. And number 2, you're going to find the domain of the composition. I'm going to shorthand it. Okay, so let's start. We're going to start back at the beginning. So first, let's just find the composition. So we have g of f of x. So I'm going to write g parentheses f of x. Okay. So our g value, we have 1 over our x value minus 2 plus 1. Okay? I'm putting a big space here because I know my x value is my f of x. I know this is tricky, so I don't want y'all to get stressed out by this. This is a tricky concept, and practice tomorrow will help solve this. So do y'all see that f of x is equal to 1 over x? Okay, you're going to put 1 over x in place of your x value. Okay? Now, we've got a fraction and a fraction. So we have a fraction of a fraction. We've got to make it look nicer. Now, this is not anything new in pre-cal. You should be able to work this out in Algebra 2. This really is just like Algebra 1 stuff. But don't get stressed out. This is not anything new. Okay? First thing is I want to get 1 over x minus 2 all under one fraction. So I'm going to say 1 over x minus 2x over x plus 1. Did I change anything about this equation except I added it to x on top of 2 and x on the bottom? Because if I cancel those, if I cancel those out, it's still 2. Okay? Now I can combine the bottom fraction into 1. I'm sorry it's so slanted. I need to work on making it not a slanted screen. I guess it's the way I write. Okay? So I combine it underneath one fraction. Okay? Now I know y'all remember this. I talked about this like the first week of school. Okay? Multiplying fractions is dividing by fractions is easy as pie. Take the bottom equation, flip it, and multiply. So in reality, this is like saying x over 1 minus 2x plus 1. Okay? Because we're multiplying by 1. Okay? I know this seems like a lot, but it's really not, okay? And not all your problems are going to be this tough. I just like giving you a little bit of harder one so you can practice it and you can see like how it's going to look in worst case scenario. Okay, just like we added an x on top of 2 and an x on the bottom of 2, we need to make this 1 value here to where we can combine it underneath one fraction as well. So let's just do a side note. This is equal to saying 1 minus 2x over 1 minus 2x, because this 1 minus 2x over 1 minus 2x is equal to 1. So now we have x over 1 minus 2x from up here, that did not change, plus 1 minus 2x over 1 minus 2x. The whole point of us doing that was so we can get the same fractions or same denominators, and now we can combine x plus 1 minus 2x over 1 minus 2x. Okay? Combine like terms, and we are done with this part of the equation. Okay, so 1 minus x over 1 minus 2x is g of f of x. G of f of x. Okay, so we just solved half of our equation. Okay, now they want us to know what is the domain of that. So the domain. Okay, as I stated up front, your domain has to satisfy the inner equation, which is our f of x. And if you don't remember, our f of x was 1 over x, and it needs to satisfy the composition. So that was our first step, and our second step is the composition one. Composition, which is 1 minus x over 1 minus 2x. Okay? We all know, because we talked about this yesterday, you can't have a 0 on the bottom. So for the first situation, x cannot equal 0. Okay? And for the second one, again, x can't be 0 on the bottom, so we have to say 1 minus 2x equal to 0. We have negative 2x equals negative 1, divide by negative 2. X cannot be 1/2. So our domain in this equation is, so domain, a couple ways you can write it, which y'all all are learning, negative infinity to 0, union 0 to 1/2, union 1/2 to infinity. That's going to annoy me. Let me change this real quick. Okay? Or I would, for your homework, I'll accept x cannot equal 0 and x cannot equal 1/2. Okay? again, not all of them are this hard in class tomorrow. I just like you seeing the main gist of the assignment. We'll talk more about this. I'll work out some more in class, but make sure you have all your notes written out, and it'll be extremely helpful. All right? Thanks for tuning in. Talk to y'all tomorrow.